REM sleep has many different brain features to it. The first of which is, as we spoke in the first episode, your electrical brainwave activity at the top of the brain, the cortex, looks almost identical to that which you have when you're awake, which is stunning because you're not conscious. You're lying completely still, no presence of muscle tone whatsoever, yet your brain seems to be just as on fire with electrical activity as it is when you're awake. Coming down a step, though, there are these unique pulses of electrical, almost like lightning bursts that come up from the brainstem up to this sensory relay center in your brain called the thalamus. And then they were initially recorded out in the back of the brain in the visual cortex. Hence, this PGO waves describes the three sites that I've just mentioned. It goes from the brainstem, the pons, up to the thalamus, a part of it called the geniculate, and then out to the back of the brain called the occipital cortex, PGO. What they found was that those bursts of PGO wave activity were very much linked to these rapid eye movements. So once you got this burst of a PGO wave, this sort of brainstem up into the brain burst, then you got one of these rapid eye movements. So it was linking something there with the eye movements. And I told you that when you're having these eye movements, that's a state where there's a high probability of dreaming. And is it a surprise then that the final destination of that lightning bolt where it sort of strikes is at the back of the brain in the visual cortex? Probably not. There's also been some links with those PGO waves and learning. Not so much that those PGO waves seem to consolidate memories. In other words, they may not be critical for sleep after learning, but they seem to be related almost to sleep and initial learning. And the more that animals learn, the greater the amount of PGO wave activity they have when they go to sleep. So PGO waves are unique. PGO waves don't simply just hit the back of your brain, though. We've now measured them in all sorts of different cortical areas, and they seem to light up. The lightning splits, as it were, and it strikes all sorts of cortical areas. So then the question was, well, let's take humans and let's put them inside of brain scanners. Let's allow them to fall into REM sleep, and then we'll start scanning the brain. What did we find? It was very interesting. When you look at the brain during REM sleep compared to, let's say, non-REM sleep, you see motor regions of the brain lighting up. You see visual regions of the brain lighting up, just as we described. You see memory-related structures lighting up, like the hippocampus. And you see emotional-related structures, like the amygdala and something called the anterior cortex, the anterior cingulate cortex, I should say. So if I were to just show you, an expert, a brain imaging map with memory centers related in terms of their activity, emotion centers, visual centers, motoric centers, and I were to say to you, Andrew, this is a scan that we got from an individual, just describe the type of experience that you think this person was having in the scanner, you would probably look at it and say, well, they were probably recollecting things from their past, memory structures. They seemed to be having a visual experience, but there was also probably movement involved in that brain scanning experiment. And also there seems to be some degree of emotionality to it. That sounds strikingly similar to what we know dreams are like. With one exception, though. Another part of the brain bucked the trend of increased activation during REM sleep. That part of the brain were the far left and right sides of your frontal lobe, something that we call the dorsolateral prefrontal cortex. Terrible mouthful, word salad. Essentially, it just means the far left and right sides of your prefrontal cortex. Those are very important for logical, rational thinking and decision making. Those parts of the brain went down in their activity, almost as though they were suppressed during REM sleep dreaming. So now let's go back to our map. You're having a visual experience. It's filled with movement and memories and emotions, but it's utterly bizarre, completely illogical, and totally irrational. If that's not a perfect neural definition of this thing called dreaming, I don't know what is. Too. And I should mention, by the way, that your dreams based on those brain scans still remained your own. You were the only person privy to the experience of the dream itself. I could stick you in a scanner and I could say, were you having a visual dream, and was it, filled with motor activity and emotions and memories? That tells me how you're dreaming. It doesn't tell me what you're dreaming.